Hello, dears, and welcome to Al-Hussaini Virtual Lab Pathology Talks, Tips, and Practical Tips. What I'm going to be sharing with you today is a nice example of diffuse hemispheric glioma, H3G34 mutant. So this is a case of a 22-year-old male patient who presented with headache and was found to have right frontal mass. And as you can see from the low power magnification, this is a highly cellular tumor composed of a proliferation of what looks like to be small cell tumor, very much reminiscent of an embryonal tumor with really entrapment of many of the neurons. So this is one entrapped neuron, this is a second, this is a third, and then we have the tumor cells in between with high NC ratio, pleomorphic nuclei, and then I'll show you a large number of mitotic activities as well, and even on other areas. So the first thing that would come to mind really is this an embryonal tumor rather than a glioma, and this is an important clue to the diagnosis. Now, on high power magnification, large number of mitotic figures. In one high power field, like 4 mitotic figures. In another one, again, mitotic activity is very prominent. However, usually vascular proliferation and necrosis are not easily identifiable, and yet this tumor, once you confirm the diagnosis, is assigned a grade 4 regardless of the presence or absence of the features of glioblastoma, very much similar to what we really diagnosed the diffuse midline glioma, the H3K27 altered tumors with. And another focus, small cells, hyperchromatic nuclei, high NC ratio, many mitotic figures, and the first thing that you would think of is this really an embryonal tumor, or could this be a glioma? And what really adds to the confusion is that GFAP, this is stand for GFAP. GFAP is typically negative in these tumors, as well as OLEC2. And here comes the confusion, because once we have a GFAP negative tumor that is further negative with OLEC2, you start to wonder whether this is a glioma or not, whether this is an astrocytic tumor or not. The pattern of staining in this particular high-grade glioma is negative staining for GFAP and OLEC2. But the clue comes here from ATRX, which is a mutant. There is loss of the nuclear stain of the tumor cells in the presence of positive internal control. An excellent clue to the diagnosis. And then we have the P53, which is usually diffusely strongly positive. The IDH is usually, or typically, is negative. The H3K27 trimethylated is retained, and the Ki67 is extremely high, similar again to embryonal tumors. So the final diagnosis in this case, when I first rendered the diagnosis, was high-grade glioma that is suggestive because of the immunoprofile, the negative negative GFAP, the negative OLEC2, the loss of ATRX, which means that this is a mutant, the P53 positivity, all really add up to suggest the diagnosis of the H3G34 mutant glioma. Now, this case underwent methylation, DNA methylation testing, and it proved to be diffuse hemispheric glioma, the H3G34 mutant, and as I alluded to, regardless of the presence of or absence of features of a glioblastoma, the necrosis, and or the microvascular proliferation, this is assigned a grade 4 tumor. The tumor is typically affecting adolescents and young adults, so the age of the patient is typical, and it typically occurs in the hemispheres and particular localization in the cortex. This is why we've seen many entrapped rather than dysplastic neurons, entrapped neurons within the tumor. Unfortunately, the prognosis of this type of tumor is extremely poor, very much similar to other histone mutant gliomas like the diffuse midline glioma. So remember the triad, the GFAP negativity, the OLEC2 negativity, and the negative staining with ATRX in the presence of internal control, meaning that this is a mutant in a tumor that looks like embryonal tumor in a young individual in an hemisphere, would really be very much suggestive of the diagnosis of diffuse hemispheric glioma, the H3G34 mutant. I hope you find this tip useful in your daily practice. Thank you.